Hello, today I'm gonna explain the game of the 8 puzzle game solving. Let's start. Actually, I started it and in here I get the output and I'm gonna show it. But firstly, I wanna define you the game. First of all, in here we already have new rights of Lala. Uh, in here, firstly, we look at the is it solvable and we'll look at the inverse count. If it's odd, it's gonna be print. If it can't be solved, but if it's not odd, it's gonna be solved and it prints that, and it returns true or false boolean. And in here we have the excuse me, yes. And in here we have the looking the arrays, checking the arrays, because it is not one dimensional, it's two dimensional. So we have to use a function like that. Actually, we can't. I mean, we can't use. For example, in here we have the main method, which is solution game, uh, which gives us the solution. And in here we looking at is it equal to the true solution. And when we look at that solution, as you see, we have, if I write like that, if, for example, um, true solution is equal to number array, which is my game array. It doesn't work, so we have the method like that, our array is equal. And let's continue with other methods because this is just using all of them. I mean the solution game. In here we have the Manhattan distance and it look at the its distance of the numbers array. Uh, we have the for loop to the check that, and just it gives the total distance of the distance. And we have the inversion count which look at the inversion of the number. Is really important because the game doesn't work with only Manhattan distance, because for example in some place right weight and the left weight equal, their Manhattan distance are equal, and the game goes to right or both in a left on every time. But if it's they are equal, we look at the inversion count of the right and left way. So it's really important to the check. And in here we have the right work. Right work does the change the main list of our game. Is in here. Let me show you the or the um, two-dimensional number array is our main array, and when we use the right work, we say it, this is my work, right? I'm gonna do the right work, change the my number array, because when we give the some number array in here, it changes the point of the memory. So when we use that, we change the main memory array. And as you see, we have the left work, bottom, top work, and right weight doesn't change the or right array. It just clones the, it just using the clone array, and it gives us the distance of the right weight. For example, as I said, if I go to right, I have the 6 Manhattan distance. If I go left, I have 7 distance, which is I can get the that 6 or 7 with this function, because it goes there with clone and it look at the Manhattan distance in here. And right way inversion is the same logic with right way. It firstly creates a copy list, and in the copy list it changes the position of the right and space position, and then it just looks as the inversion of that. Like left, bottom, top, they are always the same. and true step is the main. So I'm gonna last of look at that. The clone to numbers array, which is the, as I said, I don't want to change my main array, so I created a clone number array with the that function. For example, in top way inversion, I have copy list, and first I clone my main number array with that, and which is returns my the int in two double array, and I'm using that. And let's continue with true step, which is whoa. Firstly, we have, as you see, uh, 0, 1, as you see, and we look at the position firstly. For example, in that we get the position, in that we get the positions x and a, and we get the number array, and we get the backstep, which is in default it's nothing, but we look at in every case, is it empty or not. For example, if the 0, for example, if it's 0, firstly we look at the backstep, and if the backstep is not equal, for example, is it empty, we do the that. Because in the 0, if I have my backstep is 0, 1, I already have to go to 1, 0 with bottom. And also, let's continue with the 1, 1, which is the hardest one. Because in here, we on the center, and firstly, we defined the or right, top, bottom, left way, which are the point of the Manhattan distance, and we have the right inversion points, and we have their smallest one. And firstly, we look at all of the backstep. If they are not have any backstep, then we use that. And if we get the backstep, for example 0, 1, I have to check the 3 way. For example 0, 1 on the top way, I have to check the right, left, and bottom way. And in here, I firstly look at all of them are equal. They not have to be equal. And if they are not equal, I look at the 2, 2, 2. For example, bottom, is it smallest? Is it left the smallest? Is it right the smallest one? Or is it not? If it's, and then I check it the 3 of them, because it means their 3 are equal, which is the mohofo. But if it can't, of course, then we look at the 2 of them, left, right inversion. It means, for example, my right and my left Manhattan distance are equal. You looking at the inversion of them ways. And here I look at the right inversion to left inversion. Because otherwise it always go to right. But if right and left is equal, then if left inversion is smaller, then I have to go to the left one. This is the point of that. And we looking at in every way, as you see. And let's continue with the go. As you see, there's a lot of condition. The points. Excuse me. Move right, sorry. Solution game. So in solution game, first I have the true solution array, and in here, as you see, I'm looking after them. I want to show you my game position. For example, in some way, is it like that, and it says its backspace is that, and it look at the conditions. And for example, I want to is go. As you see, is it coming to true? Yes, as you see, in here I get the reverse of the list. As you see, it's using a lot of the way, and finally I get the reverse of the list.